Unpeeled, thanks to 3dprint.com. And today we're talking about BeamIT. And BeamIT has signed a deal with Leonardo. So this is an amazing move for Sandvik. So BeamIT is a very competent service bureau that Sandvik has invested in. They were the first to print copper with E-beam. They've been doing work for Airbus, for who else? Well, Leonardo of one, and then also for Thales and Safran and companies like that. They really do cutting edge stuff. They really do kind of really critical stuff as well. And they really know how to operate a metal 3D printing service bureau. And they're now moving more into an MRO deal with Leonardo. So the details on this are quite scant. There's a LinkedIn post essentially detailing this, but it means that for the details are that for 100 different parts of Leonardo parts have been qualified, and for at least 3 aircraft, BeamIT is going to be printing using either E-beam or powder bed fusion, more generally spare parts. Leonardo itself is an Italian defense contractor, about over 50,000 employees, 14 billion in revenues. It does a lot of different stuff. It does like IT and cyber kind of stuff, avionics, radar systems, which could be a very exciting area for them to adopt 3D printing into. It also does air traffic control systems, big search and rescue helicopters. So now for the M345, it's a trainer, a light combat aircraft called the M346, and the C-27J, which you see in front of you, which is the Spartan, which is a transport aircraft. They have now had 3D printed parts produced by BeamIT. So big win for Sandvik. So Sandvik is going from a materials producer, making steel, in a country like Sweden, which is fundamentally uncomfortable with mining and things like that, even though a lot of the country's fortunes for over 1,000 years have depended on mining. And they're going towards a much more value per kilo. So they went for lower value to kilo kind of steel to kind of branded steels for knives and all sorts of applications, to a higher value even than that. Steel powder for powder metallurgy and 3D printing, and now also like an even higher value kind of parts. So per kilo, they used to ship something like several dollars, then they went to several $100s. Now they're going to maybe several $100 to several $1,000 if they're looking at BeamIT making satellite parts and parts for aviation and things like this. Also, this is a very difficult business to dislodge somebody. If Leonardo is comfortable with BeamIT, they're in Italy, they're local, trust them, they work, they're not going to just jump ship for the nearest kind of person that could print those parts a little bit cheaper. They're going to want these parts for aviation, aerospace, to continue to function and to continue to function well. So this is a very sticky kind of long-term deal, which I think is a hugely beneficial thing as well. We're seeing the same happening in the United States of America with Syntavia working with Lockheed, and Beam is kind of like the European Syntavia, if you will. Right, it took over some post-finishing companies. It took over 3T, which is a really good service in the UK, and it really has a lot of the qualities you would need, and the skills that you would need to do really high-end, really critical production of these critical parts. And defense is an incredible opportunity. It's one of the largest opportunities in 3D. The largest opportunity is potentially space or new space, and then separate or adjacent to that defense. And then adjacent or different to that, orthopedics. And those are the 3 biggest opportunities in this business. Also because like maybe some things like automotive is bigger volume potentially, but the volume per kilo is going to be lower, of course. Here we've got a lot more quality, we've got a lot more criticality, and there's a lot more stickiness to the supplier. So the value will be much longer for much longer. Will value be much more significant for much longer. So this is going to be in my mind, it's not enough people are spending not enough time on this going forward. And going forward, we should do much more. Now, another defense-related deal is by Babcock International Group, which has introduced the first 3D printed parts for the UK Ministry of Defense. Now, Babcock itself is a 34,000-person, 4 billion or so revenue company that is very uniquely British in a way because they do a bunch of stuff internationally. They also do, I think, rail and stuff like this as well. But they do stuff like they maintain the UK submarine fleet, and they maintain 2 of the UK's bases, naval bases as well. So they're very much kind of like also routinely or a number of times have taken over parts of the Ministry of Defence. And so they're very closely intertwined with the UK's Ministry of Defence establishment. They also maintain 50,000 vehicles. So a lot of the stock of the UK's vehicles are maintained by the same company, which gives them a lot of breadth and a lot of, the same kind of skills that they need to maintain. And if you just look at the part numbers on 50,000 vehicles total, that's going to be astronomical. These guys are one of the biggest accounts, if you will, in 3D printing. So they do all the equipment management, maintenance of all these vehicles, means like retooling, maintaining them, refitting them, that kind of stuff. And now what they've done is their first metal printed parts. It's a periscope system for the Titan and the Trojan. The Titan and the Trojan are two vehicles. I'm pretty sure one of them is behind you. I think it might be the bridge laying vehicle, the Titan. I'm not sure. Anyway, the Titan's a bridge laying vehicle, and the Trojan is kind of more of a general engineering vehicle that can also like clear minefields and dump things in obstacles and stuff to clear obstacles. So these are very kind of rare vehicles in the UK's Ministry of Defence infrastructure, but they're kind of important because they don't really get replaced a lot. But if you want to ford a river, for example, one of these things is very, very crucial. So not big in numbers, but not a lot of high volume parts, but very important vehicles if you would miss them or if they would be out of commission. So, an extremely good business case, of course, of 3D printing on these extremely low volume vehicles. Now, what they've made is a periscope component for them to look at. Maybe some of them can ford rivers and stuff. You can see, I think, the periscope between the two gentlemen here in front of us. And this is a small component that they're holding for this periscope. Now, they don't talk about the technology or the material or the printer, that kind of thing. They don't disclose that kind of stuff. I think it looks a lot like a bound metal kind of component from Markforged or maybe a desktop metal printer that is using a bound metal. But it could be something else. Feel free to speculate in the comments and stuff. I would love that because I think bound metal has a really big role to play in these kind of environments. And I think that if you're looking at specialized niche vehicles, low volume parts, it's an extremely good business for 3D printing. And if these guys adopt it, the volume could be astronomically high. So, this is another example. Famously, an army marches on its stomach, and we happen to be the microwave. So I would expect an awful lot more adopted by militaries, by navies worldwide. And UK's Ministry of Defence has not been doing a lot over the past decades, but lately has been doing an awful lot in investing and bringing on board 3D printing. So they've really seen the light. And AIBuild has also seen the light in talking to AI. So what they have is they have implemented OpenAI's Chat GPT language model in their thing they call Talk to AISync. So AISync is like a kind of like a visual drag and droppy kind of like, let's say, a toolpath engine. You can program it in a very visual kind of comparatively easy way. And they've now raised the abstraction level a little bit higher with implementing this machine learning language model, GPT, which you've probably heard about by now or probably played with all sorts of cool photos and all sorts of cool other descriptions and things that you could be doing with that. So the example they give that really hits home to me is that increase the infill gradually in the last two layers to make the ears stronger in the bunny model, the Stanford bunny that we all know and love. And that kind of thing, first off, I think, it's being presented as something that for the casual user or for the maybe non-engineer, but I think it could be really valuable for engineers, 3D printing experts as well, to very quickly, imagine you're trying to do a bunny model and optimize it, and you wanted to just make the ears stronger in very, very different ways. Now, rather than modeling all of those, you could just give, or rather than changing the file, you could just give AIBuild's AISync tool the command to design or the infill of this bunny in really, really different ways and radically change the way that this bunny is printed very, very easily with very little time on your part. And then we can just test the models and then roll off the printer. So I think that's a really, really great use case. Now, on top of this, it could make a lot of non-engineering people or people that don't want to take the time to learn all the settings and all the different influences of heat and speed and all on each other. They could really use this model as we go forward, kind of, get better results. And I think that's really exciting. On the consumer side, but definitely also on the engineering side. Now, what I think is actually for this machine learning thing, I think, hey, definitely, we all agree we're going to be learning a lot more about this machine learning stuff. I don't know if you, like I am, looking for any kind of introduction to machine learning courses. I am, because it's going to change a lot of stuff, and it's going to change so much stuff. We don't even know exactly what it's going to change at this stage. So, but I think what could be really impactful for us, look at AIBuild. And what is AIBuild? Is a machine software platform that lets medium format, large format 3D printers mostly, plan the toolpath of the robot arms and their extruders for metal, for for pellet extrusion, for filament extrusion, and for lots of different kind of vendors and lots of different platforms. There may be somebody could be a robot integrator, make their own unique robot. Somebody else could make a really large kind of gantry-based 3D printing system, and these guys don't want to develop their own software. So that's where AIBuild comes in and connecting all these things. Now, imagine every single time, like, Arkema come up with a new material, and then some other, like, Caracal will come up with the new settings, right? And then somebody else, Kuka will come up with a new setting for the robot arm. Now, a lot of AIBuild's job is to maintain all these things, and it would take a lot of time. So by using these machine learning algorithms, they could, for example, dynamically update all the settings and all the settings and all the printers and all the settings and all the robot arms to each new setting in, for example, a material, or each new kind of iteration in their optimal toolpath or their generation system. So to me, this is a hugely kind of time-saving opportunity in software maintenance that I think will be applied in 3D printing, but also much, much beyond 3D printing in the year. So I think machine learning is definitely going to impact us. We're going to be definitely hearing about a lot more of that going forward, and I'm very excited about that. So thank you very much for your time. My name is Joris Peels, and this is another episode of 3D Printing Unpeeled. Thanks to 3dprint.com. Have a great day.